Hello and welcome to a flowcode video tutorial on Ghost technology. This video is going to be split into two parts. Part 1 will be looking at ICD and part 2 will be looking at ICT. These are two unique features of the Ghost technology supplied by Matrix Technology Solutions. So part 1, ICD. ICD stands for In-Circuit Debug. And what this allows you to do is it allows you to monitor the program execution. It also allows you to view and edit the values of variables. And it also allows you to do things like setting breakpoints, which allows you to examine specific portions of your code. So what does this mean in practice? I'm going to start a new project and I'm going to use the standard 16F1937 microcontroller that's found on our EB006 E-blocks boards. So I've started a new project, and all I'm going to do to enable ICD, well, I've already got my E-block board connected to the PC, and what that does is it enables these three options up here on the toolbar. So we've got ICD, ICT, and we've got some options. If we go into the options, so you can see the first two tabs are specific to ICT, and then we've got settings at the end. Now again, you've got a section at the top which is related to ICT, and then you've got some settings in the middle of the window that relate to ICD. Now we shouldn't have to touch any of these settings, but this allows us to configure things if we want to do things a bit differently. For example, if I was using the flow kit board, then I would have to specify which pins I want to use as the ICD communication pins to allow the flow kit to talk to my target processor. As we're using the EB006, everything's taken care of for us, so we don't even have to change any of the settings. So what I'm going to do is I'm going to switch on ICD just by clicking the button. It's going to tell me that the project needs to be saved because I've not saved it yet. So I'm just going to save it, and I'm going to save it as ICD. It's just confirming whether I want to overwrite a previous project. Once ICD is enabled, all the icons on the toolbar turn green to sort of indicate that ICD is active and ready to go. I'm just going to make a really simple program where I've got a variable. I'm going to call the variable count. I've got a loop. I'm going to output the value of count to port A. I'm going to increment the value count. So count equals count plus 1. I'm going to have a really short delay, so 1 millisecond. So I'm going to save this, and then I'm going to use the compile to chip to take that program, make it into C code, compile that C code into a hex file, and then transfer that hex file to the microcontroller on the EB006 board. So you can just see it's sending the program now, which might take a few seconds. Okay, so the program's sent. So I'll close the compiler messages window. I've got a little ICD board that's lit up, an ICD LED that's lit up on my EB006 board, just to tell me that the board is also in ICD mode. So I can either click start, run, or I can click step into. So for now, let's just click start, and this will start the program running on both the simulation and the hardware. So my hardware is currently flashing away. I've got an LED board connected to port A, and that's flashing away nicely. I'm going to pause the program, and you can see I've got a green box that indicates which icon I'm currently at in the program. If I use the step icon, then I can move from one icon to the next. And the green marker will show me exactly which icon is about to be executed. So if I click the step button now, it'll then perform the output functionality. You may have noticed that I get a new window that pops up when the simulation's running. This is called a simulation debugger. Now, if you're in simulation, this would allow you to do things like monitor variable values of the simulation. Because we're in ICD mode, I can do the same thing with variables, but actually it's now linked to the variables on the hardware rather than the variables in the simulation. So I've got this expression box and a small drop down. So if I double click that, then it allows me to add a variable that I want to watch. So I'll place my count variable in there, and you can see that currently it has a value of 70. As I continue to step through the program, you can see after we've called the increment function, the variable has the value of 71. And if I wrap around the program again, then it updates to 72 as expected. You can also click the value 72, and you can force your own value in there. So you could say 185, and now the value is 185. And when we wrap round to the increment again, it's now 186, and that's the value being shown on my port 8 LEDs. So you can see this is quite a powerful tool to allow you to go in and see the status of any variable and be able to allow you to change that value of the variable. Another helpful feature is you can right click any icon and you can use the toggle breakpoint method, and that adds a small red circle to the icon. Now what I can do is I can just run the program, and whenever it hits that icon it'll stop. So you can see every time I hit play, the count is incrementing by 1, and we can see that really nice and easily. This is the part of the code that we want to get to, and then from there you could say step if you wanted to look at the specifics of what's going on in a small portion of the code without having to step through every icon to get there. When I stop the program also stops on the hardware and resets, and this allows you to start from fresh every time. So you know that when you start the program, you'll be right similar to a power on reset or pressing the reset switch. So I hope you've found this video useful, and please be sure to check out part 2 ICT. Many thanks for watching.